So longevity is, of course, not just a theory, it's a biology. And in our next session, we're going to explore the cellular model of age, really decoding how exercise, immune resistance, and epigenetics really shape our health span or lifespan. And we're going to hear from leaders who are really mapping aging from the molecule to the system level and what it means for interventions today. So we're going to have speakers who are going to talk 20 minutes each, and then at the end, we're going to have a Q&A. So make sure either if you send in your questions, your Slido, or that you have some questions prepped afterwards. And first up, we have Vijay Vaswani, co-founder and CEO of Omniscope, together with Holger Heyn, co-founder and CSO of Omniscope. And they are both innovators in single-cell and multi-omics, building maps of how aging manifests in our biology, really on a mission to crack the so-called immune code. So Omniscope, just shortly, is decoding the immune system and using AI to scalably develop diagnostics and accelerate therapeutics, building the world's largest immune data bank. So please give it up for Vijay and Holger.
You are made of cells. All of you are made of cells. Not all cells are created equal. Your immune cells are what are defending you and protecting you from disease right now. They are both the detectors and the very living medicine that allows you to live a long and healthy life.
In the end, it's our immune system that keeps us healthy. Especially here in Madrid, people live healthier, longer lives, and we want to figure out why that is. So in age, specifically, the immune system is losing its function. So we lose protection from viruses, but we also lose protection from deadly diseases such as cancer. Immune cells also lose their self-control. And here they attack our healthy tissue and really make us suffer diseases such as autoimmune or neuroinflammatory diseases. So at Omniscope, we are reading the immune system. We implement a technology that reads the immune system one cell at a time. And that now, over the years, really allowed us to generate a data bank, really to understand the holistic immune system and how it acts in the healthy context, but also to use that as a reference to quantify what's going wrong in disease and what's going wrong while we age or suffer age-related diseases.
Indeed, when you think about the fundamental mechanisms that rule our biology, you could think of the brain as a central command system and the immune system as your distributed cellular soldiers. Now, decoding the immune system is not a small feat. It is an incredibly complex system. And there is not much utility in only being able to understand something if you cannot act. So not only does Omniscope read the immune system at millions and millions of cells, it writes the immune system. We write your immune system so that you can use your own immune system as a living medicine. And this is not science fiction. We've actually done this.
So we have the entire system vertically integrated, where we're reading the immune system and specifically immune system dynamics when, for example, we age, or when patients respond to treatment, for example, immunomodulating drug, immunotherapy, cancer vaccines. And here we also implement a system where we biobank healthy cells and to use those for future autologous therapy. But what you see here on the screen is actually the next phase. We are writing the immune system. In this case, we are writing the immune system of a half-a-year-old child that was suffering from a pediatric tumor. So we are working with her over the years now. She's on complete remission because she responded to immunotherapy. It's a drug that is activating the immune system. And as a company, we were following that process and we were identifying those cells that were killing the tumor cells and that were protecting the patient from the tumor coming back. So it is and it was the immune system that prevented her cancer to come back. She's still in complete remission now after 3 years. But as a company, we kind of took the language of the immune system. We took her own T cells and we engineered the T cells to recognize the tumor. And this is something that in the end is a living drug and will protect her tumor for coming back in the future.
So it's really the ability to use your own biology scalably, and scale is very important. You see, engineering your own immune system the way we've done here, using mRNA technologies, was not only fast, it was incredibly cost effective. And it was cost effective for a public health system. And at Omniscope, we believe that healthcare is for everyone. This key point, moving from immune engineering to the fact that in order to engineer the immune system and to bring healthcare for everyone everywhere, you need to represent everybody cell by cell. That's billions and trillions. You yourself have over 2 kilos of T cell dry weight within your body, up to 10 to the 16 unique combinations. And Omniscope really understands that in order to use data actionably and sustainably, we need to represent all of you, which is why we've spent 5 years building the world's largest immune data bank.
So having sequenced millions of cells from thousands of individuals in the end really allowed us to work with drug companies to develop better drug, to increase the drug development cycle, to make it faster. We were working in areas of cancer, mainly immuno-oncology, infectious disease, but also autoimmune diseases, really where we could make an impact by reading the immune system, sometimes in real time working with clinical researchers in clinical trials. But what about aging? What about being healthy? So having sequenced thousands of samples from newborns to centenarians really allowed us to understand the process of aging and to use our system as a biomarker to quantify the process while we age, or to quantify the process while we respond, for example, to gerotherapeutic agents.
And as my esteemed compatriot, Dr. Mahmoud Khan, alluded, this is not about a single nation or a single individual or an act of heroism. This is about really all of humanity. So we not only looked at different age ranges from newborns to centenarians, we also looked at different HLA types and ethnicities. We also ensured that our models are equally representative from a sex perspective, because whilst our biologies as humans are similar, our sexual morphologies and differences do mean that we react to age differently. It's really this database that really allows us to have a foundational model of the immune system. And really moving forward, it is only by building a model that you can truly act. You can only act on what you know, and you can only de-risk and intervene if you can predict and model what may happen. Thus, by building a complete model of human aging at a cell-by-cell basis, not only do we bring that to you so that you can live longer, healthier lives, we bring it to our esteemed colleagues developing therapeutics as well, so that they can use these models to test and accelerate the ability to enhance human lifespan and quality of life.
So during the next days in this conference, you will hear a lot about the hallmarks of aging. But in the end, it is the immune system that is either the root cause or an actual consequence of these hallmarks. So if, as a company, we put together a model of age that is incorporating our own proprietary sequencing methods, our proprietary machine learning models, for example, related to immune age or the inflammation process, but we also pair that up with already existing, with accepted markers, biomarkers of aging, for example, senescence, telomere length, or the DNA methylation clock. And I'm obviously very proud to have Steve Horvath in this session, who was the pioneer looking at methylation and the prediction of biological age.
And it is also an honor for us to use some of the technology which Dr. Horvath has designed. In science, we genuinely mean it when we say we stand on the shoulders of giants. And I do want to take a second to thank you for being such a major contributor to our field. Thank you. Thus, we build a model of age with respect to what has come before us scientifically, but also moving the field forward with all of the tremendous advances. How do we use this model of age? You see, now that you have a model, you can genuinely, from a public health and epidemiology perspective, look at age as a disease. Now, we often look at aging and say, well, all the bad stuff happens to us when we age. From a incidence perspective, as we age, cancer, cardiovascular disease, susceptibility to infection, all become more and more prevalent. And one of the fundamental reasons for that is an aging immune system. But I also want to take a step back. Being mortal isn't all that horrible. Other good things happen to you when you age. You become a little bit smarter. You have families. You can enjoy your wealth. You can give your wealth to better causes. You can use that knowledge to make a better world. So for us, from a humanistic point of view, we want to extend your health span so you can do more good and not just get a lot sicker. So aging as a disease is something which we show in our next slide that is not always entirely bad news. You see, I am interested in you, but I'm going to take a moment to talk about me. My name is Vijay, and I'm the CEO and co-founder of Omniscope. This is my cellular avatar. This is my actual, real cellular avatar being updated right now with my wearables, and is a digital model and representation of my own biology with millions and millions and millions of cells. It is as personalized gets.
So my name is Holger Heyn. I'm Chief Scientific Officer and co-founder of Omniscope, together with Vijay and Lynette, who's here in the audience. And this is my cellular avatar. And my question is, being here in a blue zone, how are these cellular avatars actually changing during the next days of the conference? And as you can see by Vijay and my own avatars, they look very different. And we explain in the next slides what that different actually means and how we challenge each other to get younger or older related to inflammation or the aging process in general.
So let's do the riskiest thing that you can possibly do at a conference. Let's go for a live demo of OS Lifetime, which actually allows us to look at my own immune system. So, going to the live demo of OS Lifetime, which my colleague Nina is just about to switch over to. OS Lifetime is really designed for you and for science-based longevity clinics. We believe in a world where AI and software have a physician at their helm. And Nina, if you could move to the demo. If not, I'll admit defeat at my only chance at doing a Steve Jobs, but I guess I'm not going to do that, am I? One of my major issues that I faced, which you can see in my previous slide, is whilst my date of birth is 42, my immune age is actually 60. Whilst I have practiced sports at a semi-professional level for many, many years, one of the things that I unfortunately suffer from is psoriasis, quite acutely. I inherited this as a gift from my father, although he gave me a lot more good things than just psoriasis. And the issue that I've had is that my inflammation, at one stage, when I compared it to what we had in our database, was actually as high as a cancer patient. Now, for a CEO trying to spend their life helping other people, that was not necessarily the best message I got. So what you can really see here is that now my inflammation is back to normal. Indeed, if I actually go to my actual inflammation, you can actually see how bad this got. The peaks and troughs that you see going up and down are my psoriasis flares. And the reason that they go down is because of administration of corticoids, which are a synthetic form of cortisol, a stress hormone, which has both pro-inflammatory and anti-inflammatory effects. Unfortunately, like many patients after over a decade of use, I have resistance to this therapy, and it doesn't really work. And psoriasis doesn't just attack your dermis, your skin, it can get to your bones. That's not the end which I wish for myself. And for this reason, I actually then also realized as we scroll down that not only was my inflammation off the charts, my cellular damage was off the charts. And not only am I shorter than Holger, my telomeres are shorter than Holger as well. And my telomeres are what allow my cells to constantly actually replicate. And as they get shorter, the ability for me to regenerate my cellular populations is impaired. I can also see that aside from my immune age, my methylation clock also shows signs of accumulated, accelerated aging. But let's move for a second to the presentation where I can show you very briefly what I did to reduce my inflammation. You see, I decided to use non-pharmaceutical interventions. Why? Because I wanted to contribute as an N of 1 to society and show you that you don't always need access to expensive medical care to actually change your biology. I did stuff which is quite free. I slept. I worked out. Thanks to Football Club Barcelona, I changed the way I work out, and we'll talk more about that because as you age, you need to exercise, but you need to change the way you do it. And I took supplements which are generic and cheap. Fish oil, melatonin, high-dose vitamin C. I'm publishing the entire thing and it's completely free. Don't do it without medical advice, but here's what happened to me. You see, in the next slide, you can actually see quite clearly that in just a few weeks, I went from cancer patient inflammaging to athlete fit inflammaging. And this was a major, major benefit to me. I want to make sure that using OS Lifetime, you have the same benefit. If you can see it, track it, you can do something about it.
And as initially introduced, so our technology is reading single cells, it's reading single immune cells. So we can look, switching to the next slide, really to look at the root cause. What is behind? What's the mechanism behind the improved inflammation score? So here we're looking at very specific parts of the immune system, CD4 and CD8 T cells, but those can also produce inflammatory markers. They're not only helping us, defending us against pathogens, but they can be pro-inflammatory and produce inflammatory markers that we measure in the blood and that cause systematic damage of organs. So we've seen then with correlation of the reduction of the inflammatory scores and inflammaging, those immune cells also going down. And this is something obviously we are tracking now over time. Going to the next slide, let me introduce you my own cellular avatar. So here you can see in one single view, inflammaging immune age protection score. And what you can see from my immune age that although I'm 46-year-old, my immune age is actually 37. So this is very good news, and this is something I will follow up. I will try to keep improving. Bad news, though, is that my inflammaging is very high. But the good news, again, is it's something actionable, right? Together with my protection score, displayed by the rings around the sphere, points to the fact I have a solid protection. But again, protection is cellular defense against pathogens, and that's something actionable, for example, using vaccination. Next slide, please. So here today I will walk you through starting with the view today. That's why how my immune age and inflammation looks like, to take you back in time and how the evolution of the immune age has been over the last almost 2 years. So you see kind of a constant gradient, consistent profile over the last 1.5 years, but then at the end of 2025, I was facing a disease called Lyme's disease, which is introduced through a tick bite then bacteria causing inflammation. It can have a systemic effect. So you see actually the drop in my immune age. You see through the integration of my variables, the drop in VO2 max. And all this together was a warning signal. Then quickly the disease was resolved using high-dose doxycycline. And you see actually both immune age, VO2 max going back to baseline. Now, thinking about it, it's a bit counterintuitive, right? So I'm facing a disease, still my immune age is decreasing. So I'm actually decelerating, I'm getting younger. But if you think about it from the other angle, from the kind of defense immune biology angle, it is really through a disease that is quickly resolved, we are training the immune system. It's a little bit like a vaccine, right? So we're training the immune system, we make it younger, we make it better, we make it defending us better in the future. And this is what has happening. And again, looking at the immune age model as a general, we can then look at specific populations, again, identifying CD4 T cells that are very much correlating while my immune system is getting younger and I'm responding back to baseline. These CD4 T helper cells, so those cells that are building a stable memory, in this case against a Lyme's disease pathogen, are going back to baseline. But then having the full model of age, we can look at other biomarkers of age. So next slide, please. So here, a biomarker senescence, so zombie cells that cause chronic inflammation, are actually behaving the opposite way. So during Lyme's disease, senescence is peaking, and then it's decreasing while I recover, and my immune age is going back to baseline. Next slide, please. Slide before, please. One important thing to mention is, and it's where many aging clock fail, is reproducibility. So if I send a sample, I measure it 3 times, it should give 3 times the same result. And this is what you see on the slide on the right-hand side, where we measured multiple samples repeated times, and it gave, you can kind of see that by the low standard deviations, it gave repeatedly the same result. But then we also looked at biological replication. So samples that you see in the circles, last slide please, that you see in the circles where I've been giving blood repeatedly over weeks. So these are samples taken only weeks apart. And here the immune age prediction is really following the evolution of my immune age over time while I was recovering from Lyme's disease. What you see here is really then now not only Vijay and myself, but we now are testing many individuals for years now, and you see the consistent evolution of immune age over time. But in specific cases, for example, myself suffering from diseases, you see an active training, or for example, Vijay, you see active peaks where his psoriasis flares are really acting against the immune aging clock.
So really the message here is that we've been very, very rigorous at understanding aging as a process across thousands of individuals from different age gradients, different nationalities, healthy, affected by disease, in a reproducible manner to really measure the way our age changes, both to infection, to disease, but also very important to therapeutics, as well as other interventions. But ultimately, we also need to understand, how do we compare? A model allows you to compare yourself to other people. It allows you to compare yourself to your aspiration. In the next slide, we really go into what is it that we can learn from long-lived centenarians. Omniscope has invested a significant amount of resources, thanks to our investors who are here in the audience today, to really understand that. And one of the things which Jose has mentioned, which I'm entirely aligned with, is that Spain itself is also quite a special country. It's a country where many long-lived individuals do live. What can we learn from these individuals? What can we learn from centenarians, Holger?
It's centenarians, or in this case, even super centenarians. So what you see on the screen is a study that was published about a week ago. It's a multi-omic profile. That basically means there are different layers of information, looking at the microbiome, looking at immune age clocks, looking at DNA methylation clocks. So everything kind of summed up with a holistic profile how a supercentenarian was managing to live that long. And this is obviously our North Star. And this is something what we implement in our lifetime. So you and myself, I can do it today already. I can track how my specific biomarkers of age are on track to be a centenarian or potentially supercentenarian in the future. And that's what we are all after, right?
So centenarians are the North Star, but we also have to have an idea of where do we want to get to, right? So for a lot of us, as we age, we want to retain our functionality. We want to be able to play. We want to be able to move. We want to be independent. These are hallmarks of vigor and of leading a complete life. Do you know which population has all of this vigor? If you think of it, if you think of the individuals you know who are most functional. In our next slide, it's athletes. Athletes represent, arguably, a paradigm in what it means to be fully functional, fully vigorous. They have less sickness, they have more activity, they keep more muscle mass, they suffer less sarcopenia, they keep cognitive vigor, they are engaged with their communities and their teams. They are brimming, simply brimming with life. And we live in a world where centenarians are running 100 meters and competing in incredible athletic events. If there's one common sense thing that we ought to do, it is to learn the secrets of athletes. And it is with great privilege that we have Dr. Gil Rodas from Football Club Barcelona, who is going to share with us the secrets of athletes.
Thank you very much. First of all, I would like to talk with a microphone. Is this possible? Oh, he's here. I'm sorry. I didn't see. Hola? 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 Fantastic. Well, first of all, I would like to say thank you very much to the organizers for this great event, and especially, of course, to Omniscope. Why I am here? From Football Club Barcelona, in Madrid. Well, I am a privilege because I am working on probably one of the best football clubs in the world, but at the same time, I am a privilege because I am working also in one of the best hospitals in Europe, that is Hospital Clinic and Hospital Sant Joan de Déu of Barcelona. For this is nice in order to share this double vision from sports to the health, to the sports, okay? I am a sports physician, and now I believe that you are a little bit tired, because after 1 hour and a half or 2 hours sit down, please, I think that it will be fantastic if you want to stand up and move a little bit. Yes, fantastic. How many people are suffering low back pain now? Because no? Thank you very much. Okay, sit down, please. Well, next slide. Why we are here? It's true that during many years, I have been researching with these guys, with these athletes. No. And these athletes are really different. Sincerely, I had the privilege to be their sports physician during many years, from Messi, Iniesta, and Ronaldinho. And believe me, they are different. They have some special things that we need to know, not only in terms of the genes, if not in terms of how they adapt depending on the epigenetic factors. And this is a great secret that I can have the possibility to know it. Not just only in terms that to help Football Club Barcelona to be greater than Real Madrid or Athletic de Madrid, but also for the future for the general population. And this is a question for you. And I hope that you answer me at the end of this short speech. What do you believe is I say that these athletes probably will have longer lifespan and better health span than all of you? Do you believe that this is true or no? Please, wait a minute. I have the answer, the scientific answer, but please, that is true that everyone in the world think that this is not good. Well, next slide, please. Of course, the cancer in the world of sports is injuries. Yesterday, Real Madrid and Athletic de Madrid won. That is fantastic, but as you know, there are many players that have suffered different kinds of injuries. And our cancer are injuries. Our players are constantly in an inflammation process. All the players that played yesterday, today have inflammation. And you can imagine that this, during 20 years, 25 years of your life, every day you are suffering an inflammation. For this reason, when we, as a doctors, we need to know more about the health of our players and to find a good biomarkers in order to help the health of my players and at the same time increase the performance of my players, I found Omniscope. Because it's the first time that I see something that can help me in order to know the immunologic status of my players. Next slide, please. This is a dream or no is a dream. Today, we create, thanks to these partnerships, a good avatars of every of my players. Why? Because I need to anticipate when this player will suffer another injury, or when this player will suffer an increase or a decrease of his performance. For this reason, today, we have the possibility to create this avatar using the digital twins technology. Repeat, this is not the future. I'm sorry, this is the present. Next slide, please. In terms of, that is difficult sometimes, we need big data of every of our players. In terms of from omics, we are talking about the genes, transcriptomic, proteomic, metabolomic, epigenetics, also immunologic profile. But we can incorporate and integrate radiomics, GPS, because we have the possibility to know exactly the load of our players during all their career. Load is very important because they need to adapt every day to the training. You can imagine it today to talk with the players of the Real Madrid and say, how are you? I am tired because yesterday I played. And how is your muscle? Is okay? You're hurt. How is your immunity profile now? We need to know this. It's true that sometimes the players don't like that you know everything about them, because maybe yesterday, after the match, they went to the party. But repeat, we need to know this, because probably this weekend, when they play again, some of these players will suffer injury. And then is when the coach say, hey, what's happened here? What's happened? If you allow that these players play every 3 days, probably you will have injury. Well, thanks to this kind of universal biomedical, we have the possibility in terms that to anticipate. Next slide. Thanks to Omniscope Sports, we are creating this. This is possible. And this is sometimes is more difficult to convince to the coach that this tool can let him to have more information. Finally, the decision is from the coach. The coach is the man in the world of the sport world. In the hospital is a doctor, but in the sport is the coach. Coach is the boss. But coach needs to believe in this kind of tools. But for this reason, these tools need to be very rigorous. Next slide, please. We create these profiles. We have these tools. Of course, the doctors are very, very happy with these tools. Repeat, every day we are increasing the information about every of our players. Next slides, please. This is very interesting, but of course it's very necessary to be very rigorous in others, not to send humo. No, this is science. Next slide, please. We did some research. Real Madrid probably is the best sports team club in the world in terms to win European championships. But sincerely, I believe that Football Club Barcelona probably today is the leader in sports team research. Because in the last 10 years, we have invested a lot of time, more than money, in order to have this research, in order to now to show you. This is that is an example that we are doing now with Omniscope in terms of how change the immunology age in function about your position. Next slide. This is an example. And this is a little bit more that I would like that Holger, can you explain me this last research that we are doing?
No, for us, so what you see is the immune age evolution of a player over the course of a season. And for us, it was incredible to see that immune age now as a metric of immune fitness or fitness in general is changing very rapidly. And it's not changing consistently across the entire team, but there's actually correlation. So players that play more matches, players that move more, age faster. Strikers, so forwards, age faster than midfielders or defenders. And what you see in this slide is the very high resolution picture where we correlate immune age together with GPS data. So football players are probably the best profiled players on the world when it comes to movement. So movement in general, but also impact. And this is all represented by different GPS metrics. You've seen on my slide that we have wearables integrated from the, for example, from the Apple Watch, VO2 Max, heart rate variability. So here this is very different because we have much more different metrics that we can correlate. And for us, it was incredible to see that GPS data, so the external load, is translating to very different internal load of a player. And immune age has been our sensitive metrics to quantify this.
Thank you, Holger. Next slides, please. And what about epigenetics? Of course, we are genes and how we can adapt to how we are sleeping, nutrition, training, travels. Epigenetics, of course, is very important. And probably we need a good balance between genetics and epigenetics. Please, next slide. But today we have the opportunity also to work in terms of the methylation, etc., in order to know this another aspect is how our players have adapted to that training, to the competition. And for this reason also we have another partner that we are working on and researching in terms of to know the epigenetic age clock, the telomere-related age clock. Maybe later another speaker can talk about more of this. But it's interesting to know, for example, that our players, for example, have this, specifically in male athletes, in football male, they are a little bit older than the normal population. 2 years more. But in female teams, no. And this is another message. We need more research in terms of female teams. Because in terms of the female, we don't know anything. When we are looking for some biomarkers in terms of transcriptomic, proteomic, metabolomic, they are different biomarkers for female and male. And for this reason, we need also, remember, to research in women. Next slide, please. And this is one of the latest studies that we are doing that just only with some epigenetic, we have the opportunity to know the relationship between the load and some biomarkers that can help us in order to anticipate different injuries. Another slide, please. Fourth, at the end, understanding an athlete's immune, epigenetic, and genetic profile may help with personalized preventive strategies. This is the key. Sometimes the people say me that, doctor, are you doing a genetic and epigenetical test before hire contract the players? No. But when we contract a new player, I need his permission in order to do this kind of test. But I think that this is good because he knows, and we know, which are the risk factors in different areas. And for this reason, we can create a specific strategic, preventive strategic to help him in terms of health and performance. And the last, next slide, please. This is the coach. Remember, in the wall of the sport, this is the boss. But he believed in this. And we try to explain them to the coaches that a first step towards personalized and precision medicine in the world of the sport is fundamental. Is fundamental. I think that this is my last slide. Thank you very much for your attention.
Dr. Rodas, thank you so much. I think we're uniquely privileged because we can learn the secrets from these elite athletes. And with Football Club Barcelona, we are working really, really closely to bring the best type of science, which already as an accredited FIFA medical center exists, and put this all together. But you see, at the end of the day, I'm certainly not an athlete. So my question to you is, when we look at athletes, do they actually live longer, healthier lives compared to the general population?
Well, this was one of the meta-analyses that in part create evidence, scientific evidence, that these kind of guys, these kind of athletes, of course, have a span life longer than all of us. This is true. For this reason, I think that we need to learn about this kind of special population. ¿Vale? It's true that maybe they will have more problems in their knees or in their hips, okay? But in terms of less disease and long and lifespan longer, this is the answer.
Well, I guess the natural next question is, we see that with a free, non-medical intervention, exercise and sport, we can see scientifically that we lengthen life and reduce the risk of many diseases, including cardiovascular and cancer. But a lot of us in the audience, and even for what you saw on OS Lifetime, using our wearable data, we're not training like athletes every day, right? So in order to get the benefit to live a longer life, do you need to train 8-10 hours a day like an athlete? What do you need to do?
No, but we need to do exercise. And this is another question. It's the last question for you. I would like to know if you can do some exercise every week. How from here, how many of you are doing exercise at least 3 times per week? Thank you very much. You are really, really incredible. Well, but it's not necessary to do 10 or 12 hours per day, no. But that is fantastic. Thank you very much. I think that this is a great population.
Did you want to add anything?
Just a final announcement. So you have seen our both OS longevity profile, but we also want to bring OS longevity to you. So that's why it's our honor to announce today our partnership together with the Sen Clinic in Stockholm and Sweden. So here, I've been visiting Sen Clinic for the last couple of weeks, and it is a perfect match where science meets clinics. So I have been very impressed the implementation of geoscience and therapeutics. And moving forward, we want to see OS Lifetime being applied. And Sen Clinic is the perfect partner in crime for us.
So if you're looking for science-based longevity care to increase your health span, together with Omniscope technology, both the Chief Medical Officer and the CEO of Sen Clinic are here in the audience with us today. And I personally think that it is one of the best clinics around in a country which is very much health focused. So why are we bringing this to you? In the spirit of public health. We don't just want another health tool. We're not just here to take care of 1 or 2 people. We want to make the world a better place before we leave it. And the only way to do that is to invest in yourselves. It's to invest in your own lifetime, to have a technology which allows you to achieve your goals. And today, as a thank you to Jose, we would like to give one full package of OS Lifetime, which is the same technology which Dr. Rodas presented, to allow you to become part of this community. So grab your phone, grab the QR code, because one individual in this audience today will win your OS Lifetime. And on that note, I wish you a long and healthy life.
Thank you. I was just about to grab my phone because I definitely want to win that, but I guess I have to give it to the audience. But thank you so much for a great presentation. And it's quite synchronistic because I know the SAND clinic and I was actually thinking, I think they need to meet Omniscope. And here you are having a fusion. So I can definitely verify it's actually one of the role model clinics. So thank you so much. And hopefully I have time for a bit of a Q&A. I'm just going to introduce the next speaker of this session.